Right. Good afternoon, everybody. It's a real pleasure to be here with you. Can you all hear me okay? All right, fantastic. Great. Thanks for the intro. As was said, I'm going to be talking about the mobility industry and designing specifically sustainable mobility and the challenges, the opportunities, and the challenges and the changes that we're facing in this sector, which are, it's an era of absolute fundamental change that we're going through again. And I've selected some themes that I wanted to talk about, and I've illustrated those themes with some examples of the work we've done. So it's a bit of a showcase of some of the work we've done, highlighting some of the themes that are affecting our world of design and specifically for designing mobility. Just a little bit about myself. I've graduated initially as an engineer, mechanical engineer from Leicester University, and then went on to Art Center College of Design in Los Angeles. Graduated as a transportation designer, worked with Volkswagen Audi. And then I spent 15 years in Italy, where I ran one of the studios for Pininfarina. I then worked for an American company, Brunswick Boat Group, got about 20 brands, Brunswick, Mercury Engines, Boston Whaler, etc. And I was their design director for 5 years. And then for 14 years, I've set up my own consultancy, Astheimer Design in Warwick. So when you add all that up, I think it adds up to about 30 years, maybe a few more months. So it's 30 years in the industry, and during that time, there's been one. As I sort of got into the industry in the early to mid 90s, there was a fundamental change with the introduction of the computer into the process. The computer and digitization, so 3D milling and 3D printing, VR and AR to follow. I remember at Pininfarina we bought a very early 3D printer which printed glue into a big pot of chalk, and out came this 3D printed piece, which, if you were lucky, it didn't crumble in your hand, and we were just blown away by this technology. Obviously, things have moved on, and continue to do so. But we're really moving into another era of fundamental change, and I think it's a bigger step forward, not just with the tools that we're getting at our disposal, in particular AI, which is confusing at the best of times, and confusing the work processes and students and professionals alike, but also the context of what we're designing for. So, with the obvious push towards sustainability, with the issues of climate change and pollution and what have you, the context and the legislations that are now changing. These are bringing further contextual changes to what we're designing. Yeah, let's just hope that the politicians don't kick that can too far down the road. I think it's at 4:30 today. Sunak will be delivering his speech, or whether he's going to kick it down to 30-35 or not, we'll see. Anyway, I won't. I've got some opinions on that, but I won't go into the politics on that. Anyway, let's begin. Astheimer Design, we're based in Warwick. We're 12 people, designers, modelers, visualizers, and design engineers, and we are focused very, very firmly on the creation of mobility solutions for a sustainable future. That being said, we do work on a bunch of different projects. consumer electronics, mobile phones, furniture, etc., etc. And I think that's good because it enables the designers to work on different things. There's a good cross-pollination of technologies and know-how, and it keeps the mind fresh in terms of creativity. So just a selection of some of the projects that we do, have done, and can show. A lot of this stuff, obviously, we can't show. As a consultancy, a lot of the stuff we remain confidential, especially until they've been launched, and often even when they're launched, we can't say we've worked on them. But a real broad spectrum of mobility, from aviation to marine to commercial vehicles, leisure vehicles, personal mobility, commercial mobility. Yeah, it's a great place to be in. It's an area that as a team we're passionate about, and the projects seem to becoming more and more varied, which is fantastic. It's great just to hop around the desks and see the variety of work that's being done. We work with a whole bunch of different clients, and we work in a real collaborative way, not just with the clients themselves, but with engineering providers. Obviously, being 12 people developing a full vehicle, we need to work with other service providers, so engineers, software designers, manufacturing engineers, to get the job done. And much like actually, I really like that presentation from Nexus. That's been one of our very firm philosophies in all the projects we work on, is that it's fundamental to have that seamless communication between disciplines and the real-time communication. So the more tools that help us to do that, absolutely the better. We work from an end-to-end process, right from that very beginning phase of the positioning of the product, the brand identity, the design identity, the vehicle architecture, through to the design development, and through to functional prototypes, road legal functional prototypes. And we sort of split it up on a macro level, really, of three different phases of work. So the understanding, so really understand who your customer is, their needs, their desires, their pain points, the competitors, the technology that's usable, the brand identity, understanding how that, and really focus in. As a consultancy, we don't have the time scales often that the in-house design studios have. So it's all about aiming and being very, very focused on where you're exploring, doing that exploration, and then executing. And being a small team, we pride ourselves on being flexible, dynamic, and tenacious, getting the job done and doing what's needed to get the job done. And I think the people that really thrive in our environment are the real tenacious individuals, not least Alex, who sat here at the front. Some of the themes that are really affecting mobility and affecting the design of mobility. The changing context is one which is evolving, and it'll change this afternoon at 4:30, or it might not, who knows, but it's changing all the time. Vehicle architecture, with the electrification, we don't need the cooling up front of the vehicle, so we can change that vehicle architecture. There's that opportunity to change vehicle architecture, which is fascinating. New types of vehicles. The electric motor has enabled the ability of vertical takeoff aircraft, but also of foiling craft as well, and the size of the motor, the ability to feed it with a wire, or rather than a drive shaft, enables different vehicles now to become valid. And then just a brief look at the future at the end. So these are some of the themes that we'll be looking at. And I'll illustrate some of these themes with a case study that we've done, especially the first one of changing context, which I guess is pretty topical today. And this is a project that we've done, and the most recent project that we've launched. It got launched at LCV at the start of September. So, changing context. It's the cities and the big cities which are leading the way in change. It's actually the mayors of the cities actually have pretty much more power than the prime ministers or presidents or whatever of a lot of countries to dictate what happens in their city, as we've seen with London and Sadiq Khan holding up his ULEZ change of legislation, and based on this scenario and of this context, we created a small consortium along with ProDrive and an entrepreneur who is driving the project to create a small pedal assist vehicle intended principally for ride sharing. And so this is the first real showcase to show the process that we've been through. And I think it illustrates really well the process that we go through of design, development, and prototyping. And it shows that that a very rapid product development process that we go through in the studio. So onto the design. The design, we knew it wanted to be a 1+. So we created an initial package that would allow for the motors, the batteries, the ergonomy of a single driver plus, and the idea of this pedal assist vehicle was to really extend the inclusivity, of rideshare vehicles. The cycles and scooters are principally used by young males. Very few females actually use the bikes, the Santander bikes in London, for example, or the scooters. So there's obviously a need for inclusivity, and there's obviously a need, if you want to carry something, what vehicle can you use? So this is aimed at that target market. There's obviously a place for a scooter. There's obviously a place for a bicycle. Great products, electric bikes, but there's obviously a gap in the market for an inclusive product of this type. So we wanted the design to be inclusive. It needed to be friendly, but it needed to be a desirable product, look dynamic, and attract people to use it. So that was the sort of the briefing that we set out. We generally set out a mood boards with the imagery that creates that sort of feeling, and then from there the sketch phase. Pretty quickly from there we develop a quick CAD models. So we move into sub D. So very quick CAD models, which then express that design intent over a package. These are quick renders out from there, made to look a bit poppy and fun, expressing the character and the nature of the vehicle. And then from there, these get developed into full computer-aided styling models. We go into NURBS. We generally use Rhino. We have Alias. We use other sub-D modeling as well, but our general workflow is generally Blender, then through into Rhino, and then render in, again, a variety of softwares depending on the type of vehicle, the type of product that we're rendering. I think in this case these are V-Ray, but it could be Blender, it could be well, there's a variety of different V-Red depending on what we're doing, whether we're going into VR to analyze the product or not. It's very much designed around the user, this product, and for simplicity of use. You're going to have different people hopping in and out, so it's absolutely fundamental that the product is simple and intuitive and adaptable for the different heights, sizes of people. And this is just some of examples of the use cases of this vehicle. Not least the when it's bad weather, you don't particularly want to be on a little scooter, but having a canopy above you absolutely will help. So just some of the few images of these are CAD renders of the vehicle in use. And then on to the development of the actual prototype. So the way that we've worked with ProDrive in this instance is that they were responsible for the drivetrain system and the chassis, and we were responsible for all the touch points of the product. So all the bits that you see basically, and the ergonomics of the vehicle. So once we've got a CAD or a CAS, a styling freeze, a design intent, there's obviously that need for close collaboration with the engineering team to define the architecture of the chassis, and then we go through a phase of a build strategy, right? How we're going to split the parts out, how we're going to build the parts, how they're all going to get together, how do we maintain that fit and finish. And so we explode out the CAD, create that build strategy, and that's done through the design engineering department of the studio. Just something to highlight, I think, which was particularly of interest in this, very small vehicle, and you want to keep it as absolutely as small as possible, was the ergonomics. So there's going to be a lot of different sizes of people here, and the first aspect, obviously, and there's a lot of different moving parts. So you've got the pedals, you've got steering wheel, you've got visibility lines, you've got to get in and out. So it's slightly more complex than just a standard seating in a car. There's a lot of different moving parts, and the thing that we decided that we needed to prioritize was the sightline. So this sightline, no matter what size of person was in this in the vehicle, the sightline needed to be respected to make sure there's a key safety factor. And then with that, we needed them to be able to obviously reach the handlebars and to reach the pedals and not have their knees hitting their elbows or handlebars, et cetera, et cetera. So it's quite a puzzle. So the design engineering team, led by Alex, we facilitate these constraints with Grasshopper, so a parametric software with the algorithms to say, right, we want to protect this sightline, but we want these other parameters respected. So the ergo men of different sizes then need to reflect that, and then we validate the CAD with physical mock-ups where we test with a 95th percentile. And here we have a girl who's very much on the smaller side. I think she's 1.40 m. So she's down on less than 50 percentile on the female side. And you can see how then this mechanism, which was created by ProDrive, based on the parameters that we set them, that she has got the same eye height as Johan here, who's pretty much 95th percentile. So yeah, it's just I think it's a really nice illustration of design and engineering working very closely together and seamlessly together, and creating what she said was the most comfortable cycling vehicle she'd ever been in. She's always suffered with, getting on the Santander bikes and what have you. So I think, that's a really nice example of that close collaboration and the development of the ergonomics. The chassis was built at ProDrive, got sent up to us, and that's where we installed all the body parts, the body panels around the chassis. This is a one-off initial prototype. So in the design for manufacture phase, which is still to begin, there'll be a whole VAVE process which will go into, again, a design for manufacture. In this case, we needed to get the job done very quickly. So a lot of the parts were 3D milled. A lot of the parts are 3D printed, some vac formed. But that whole process needs to start again. But a design intent was there. This is a proof of concept. So that was the key objective of that. So that got put together in our workshop downstairs, and then it was launched, and it was launched at LCV this year, and received very good press. So we're still to await to see what happens next, but hopefully we go through into the production readiness phase for the project. But this is an example of what do our cities need for the future. In my opinion, it's the most important thing that we can think about in this new context of sustainability is efficiency. Especially as we move into the electrification era. Excuse me. The most efficient vehicles, electric vehicles, are small vehicles. The smaller you get, the lighter you get, the more efficient they are. And that's true with any vehicle, but the difference with a battery electric vehicle is you need to carry the batteries around. The bigger the vehicle, the bigger the batteries, the more you need to carry around. Slight difference to an ICE. So light weighting is absolutely fundamental, and the thought process of efficiency and everything that you do, I think, in the design of these newer vehicles is fundamental. As I mentioned before at the beginning, another theme that electrification will allow us, the opportunity really that it allows us is to change the vehicle architecture. And a great example of one of the projects that we've done is the Volta trucks. So the Volta, they weren't yet Volta, but the founders came to us back in 2019, entrepreneurs more than sort of car people, and said, right, we know that there's a business opportunity for a mid-size truck. Had no idea what the truck size would be, how it would be. So we started and created that product development journey with them, and laid it out with them, went to see the customers, understood their needs, and quite quickly we decided, right, it's going to be 100% electric. It'll be urban delivery, 16 to 19 tons, and the opportunity that we had was, we could move the batteries and the drivetrain. We're using an e-axle into the ladder chassis. So that allowed us complete design freedom in the cabin. And just at that time, a document came out from the DFT, the Department for Transportation, about HGV safety in cities, saying that whilst only 4% of road traffic were HGVs in city centres, over 50% of deaths to vulnerable road users, meaning pedestrians and cyclists, are caused by HGVs. So I mean that's an awful percentage there, and their absolute number one cause of these accidents was direct visibility. You're up in HGV, you're up, almost a metre and a half. Your H point's a metre and a half. Your eye height's above 2 meters, and you lack that direct visibility with the vulnerable road users, and the visibility out of these trucks is pretty awful when you're up there. Plus, there's a myriad of mirrors and screens that get put on, so that cognitive overload added to that lack of direct visibility was creating these incidents. So our 3 design principles for the cabin were safety through direct visibility principally, was for efficiency, to enable the driver to get in from either side. If you're in an urban area, it's much better to get out and in curbside than it is roadside. But you might want to be able to get in from either side, being in an urban area. Plus, our 2 key markets were Paris and London. So a central driver then became, quite obvious, the obvious solution. And then the driver environment. There's a real lack of supply of drivers. And so we wanted to make that driver environment as inviting as possible. So those are our sort of 3 key pillars to the design of the vehicle. And we put the driver eye height at 1.8 meters, which is pretty much what a bus is. Hence why this truck actually looks quite like a bus, quite intentionally. So it's not obviously only in trucks, but there is the opportunity to really rethink the way that we design and build vehicles with this opportunity of the electric drive systems. As I said as well at the beginning, the smaller motors being remote from the principal part of the vehicle are creating just huge new opportunities. And one of the biggest opportunities, whether the eVTOLs will, excuse the pun, take off one day, who knows? Hopefully they will. But the one thing that is happening and is revolutionizing the marine industry is foiling and e-foiling. When a vessel gets up on the foil, powered by these electric motors, which are at the intersection between the wing, the foil, and the vertical, like a torpedo shape with a propeller at the back. Once they get up on the foil, they're using about 20% the energy that they would be as a planing vessel would be. So it's an incredible increase in efficiency. And you can, as you get up onto the foil, you literally dial back on the throttles, and the vessel just flies. So Artemis Technology is a really interesting company. They're a spin-off from the Artemis race team, so America's Cup race team, that developed the technology for the America's Cup. I don't know if any of you have seen the America's Cup or Sail GP. I mean, that's that technology and the advancement in performance of the America's Cup and Sail GP, which is the year-round race foiling race circuit, where they're going up to 100 kilometers an hour, 3 times the speed of wind. So I still haven't quite understood the physics of that, but there they are. They're doing 3 times the speed of wind, and it's absolutely amazing. But this is an area which is really revolutionizing marine. And here are just 3 examples of the boats that we've designed for them that are going to production. This is a 12-meter ferry. This is a patrol boat, 20-meter, and this is a 24-meter ferry, which carries 150 people. So it's a bit like seeing a jumbo jet take off, really. You can't believe the thing's actually going to take off, but you know, with about 12 knots of speed, it starts to take off, and then it flies. You know, it's flying. It's a flying vessel, really. It's just that the wing is in the water. So, you know, that's been a fascinating process, and again, really close collaboration with the naval architects there and the simulation teams. I remember when they launched their first workboat, they trialed it the day before. All the press and then the mayor was there, and I was like, bloody hell, that's cutting a bit fine. They said, yeah, well, we've done the simulation. We knew it was going to work. It's this whole, and as well with the racing, with America's Cup or Sail GP, they're developing new foils that they put onto these boats, and they stick them on the morning before they're racing. You know, they've never tried them. You know, they'll check the wind speed. Right, we'll use this foil. They've never used it before. Bang, on it goes. Out they go, and they're racing. You know, the level of simulation to develop this technology, you know, is incredible, and it's the simulation that has allowed the development of these vessels. The first foiling vessels, if you think about it, were back in the early, 1913, I think was the first one done by a Frenchman, and it was all done on trial and error. You know, right, we'll put some wings in, we'll put a few in, bigger ones, smaller ones, and we'll see what happens. Simulation and digital twinning is obviously allowing an incredible amount of development in an incredibly short amounts of time. A change of mindset, and I think this is something that we're going to need. And I think, you know, thinking about what happened with COVID. You know, COVID came, we needed to change, we changed. You know, the climate crisis is a longer burn. I don't think there's any doubting it. But because it's a longer burn, we're, you know, let's kick the can down the road. If we need to change, we can change. And Aura, this concept, it's a road functional legal concept that we've built. Is a bit of a provocation, really, about what the sports car of the future could be. Not should be, but could be. So rather than it being a track vehicle with huge amounts of downforce, the idea of this concept was that we wanted to call it Land Glider until Land Rover stopped us calling it Land Glider. But that it had very little downforce, almost zero downforce, and it glided through the air. And that the idea behind the whole of the design of this was about efficiency and creating long range, and it still being a visceral driving experience. No windscreen on there. That was mainly due to cost, actually, rather than a choice. But the idea of it being that performance was about creating range and being able to get out into the countryside and enjoy nature, rather than tazzing it around the corners, which is also fun. But this is a slightly different provocation about, right, we need a change of mindset. We need to find enjoyment with other things. And then on to the future. I read something actually on I think it was Tuesday, which was yesterday, which I think summed up to me really what artificial intelligence and how we should consider artificial intelligence and the impact it will have on our processes. And it comes from a guy called Robert Hooke back in the 17th century, and a polymath, which I had to Google, which means a very learned person, by the way. who said, when it was at a time where there was the development of the microscope and the telescope, and his description of it was, and his phrase about it, is that these instruments were the adding of artificial organs to the natural, which I thought was a fantastic way of describing what a telescope and a microscope are, but very much as I think we should see, especially I'm talking about the design community and designing mobility. I think we should see AI really for what it is, which is another toolkit, another part of our toolkit in our development process. And I think the important thing in the design process is that we understand the context, we understand we understand all the tools that are available to us, and we create the most efficient and effective process. But really, the most important thing is the creation of meaning in the things that we do. That we're doing things that make a difference. We're doing things that improve the products, and we're doing things and products that are fitting the new context, the changing context with which we're living in. Anyway, so I just wanted to end it on that note. Thank you all for your time. Thank you very much.